Hi class, it's me, Mr. Morris, and we're talking today about AP Chemistry topic 7.6, which is properties of the equilibrium constant, which you know as K. To get started, the relationship between K and chemical equation, that's the first thing we want to talk about. This is basically talking about how the equilibrium constant will change if we change the coefficients of a chemical equation. We've got several examples here. Our original equation is 2A plus B yields 3C. I'm going to call this reaction 0, and it's our original equation. Well, the equilibrium expression, as you ought to be able to figure out by now, the equilibrium expression for this would be K equals concentration of C cubed. That cubed comes from the coefficient of 3, divided by the reactants, which is A concentration of A squared because of that coefficient, times the concentration of B, no coefficient, so we don't have a power on that one. Now reaction 1 is given. A plus 1/2 B yields 3/2 C. K1 is C to the 3/2, because of the 3/2 coefficient, over A, concentration of A times the concentration of B to the 1/2 power. So what's the relationship between these? Well, the reaction 1 relationship to the original reaction is that it's half the value of the original reaction. So 2 times 1/2 is 1. We've got 1 times 1/2, just 1/2. 3 times 1/2 is 3/2. So reaction 1 is just 1/2 of reaction 0. What about the K relationships? The first one is C cubed. Second one is C to 3/2. A squared, we got A. B to the 1/2. It looks like we took the whole expression, K0, and raised it to the 1/2 power, which is exactly what we've done. K1 is K0 to the 1/2 power. And if you raise something to the 1/2 power, your exponents will be multiplied by 1/2. So we end up with C to the 3/2, A to the 2/2, which is just 1, and then B to the 1/2. Let's look at reaction 2. 4A plus 2B yields 6C. This is the exact same thing as this reaction, except doubled. Reaction 2 is 2 times reaction 0. Look at our equilibrium expression for reaction 2. So K2 is C to the 6th power over A to the 4th power and B to the 2nd power, B squared. Well, since I multiplied by 2, it looks like I've actually just raised the K value to the 2nd power. K2 is K0 squared. So when I double the coefficients of the reaction, I have to square the K value. K2 is K0 squared. So we could take the K0 expression, C cubed over A squared B. If we were to square that, it would be C to the 6th over A to the 4th, B to the 2nd. And that's exactly what we have here. Reaction 3. This one might be a little harder to see for some at first. But 3C yields 2A plus B. Well, 3C was the product up here. 2A plus B, those are the products down here. They're reactants in the original reaction. So this is just the reverse reaction. It's reaction 0 flipped. Reaction 3 is reaction 0, but flipped around or reversed. K3 is A squared times B divided by C cubed based on that coefficient, which if you compare it to the original K value, it's just the inverse of it. It's the reactants over the products instead of products over reactants from the first expression. So K3 is K0 to the -1 power. It's the inverse. It's 1 over K0. K3 is K0 to the -1, which is going to just result in this whole thing being flipped upside down, where C cubed becomes the denominator, A squared B becomes the numerator. All right, the original reaction, again, we've got 2A plus B yields 3C, and we've got our K0 expression. Now we've got another reaction, reaction 4. 3C plus 2D yields E. So our equilibrium expression would be concentration of E over C cubed D squared, which is what you see here. You can see that if we add those together, we get this reaction, reaction 5. We just canceled out the 3 C's and we end up with 2A plus B plus 2D yields E. This is reaction 0 and reaction 4 being added together. Reaction 5 is reaction 0 plus reaction 4. Now let's look at the K values. The C cubed could be canceled out. If I multiplied these, I would just have E over A squared B D squared, and that's what we have. So K5 is actually K0 times K4, where K0 is represented by this expression, K4 is represented by this expression, and if we canceled out those C cubed factors, we would end up with this, which is equivalent to K5. Let's do some calculations based on what we just talked about, those 5 reactions we just talked about. First of all, if I took reaction 0 and multiplied it by 1/2, what would I do? Well, I need to raise the K0 value to the 1/2 power. In other words, 450, because that's what K0 is, it's 450 to the 1/2 power. You could also say we're taking the square root of 450. You end up with 21. This is, again, because reaction 1 is 1/2 of reaction 0. If you look at the coefficients, reaction 1 is the same as reaction 0, except it's 1/2 of its value. Then we have 4A plus 2B yields 6C. Well, that's similar to reaction 1, or I'm sorry, reaction 0. The difference is I'm doubling it. Now, if I double it, that means I need to take this to the 2nd power. So K0 squared, or 450 squared. We get 2.0 times 10 to the 5th. This is because the reaction was multiplied by 2. Then I get to the next one, K3. If I want to find K3, we've got to figure out what was happening to the reaction. Well, I have 3C, which I can find in the first reaction as a product. 2A plus B, those are the reactants in the first reaction. It's the first reaction, but flipped around. So I'm going to do K0 to the -1 power. It's the inverse, so I need to raise it to the -1 power. So I'm going to take 450 to the -1. In other words, I'm doing 1 over 450. You end up with 0.0022 because reaction 3 is really just reaction 0 flipped around. Now we have 2A plus B plus 2D yields E. That's reaction 5 from above. It's this reaction right here, which was the first reaction plus reaction 4. So if I have reaction 0 plus reaction 4 being added together, the reactions, then their K values need to be multiplied. 450 times 6.7 times 10 to the -3rd. I end up with 3.0 if I'm rounding to 2 sig figs. And this is because reaction 5 is really just reaction 0 plus reaction 4, which means we have to multiply their constants by each other. This just kind of sums up what we've talked about so far, changing stoichiometric coefficients. When the stoichiometric, or the coefficients in a balanced equation, are multiplied by some factor, the K is raised to the power of that factor, whatever it was. K to the n, for example. So here's a few examples of it. When the coefficients of a whole reaction are doubled, we're going to square the K value. When they're tripled, we will cube the K value. And when they're halved or multiplied by 1/2, K is going to be raised to the 1/2 power, or you take the square root. Reversing equations. If you reverse an equation, you take the reciprocal of K, K to the -1. If you're adding equations together, you need to multiply the respective K's by each other. That's the last example we did. K1 times K2 times K3, etc. if you're adding up multiple equations. And sometimes we'll be doing more than one of those things at the same time. We'll work through some examples. Okay, so using the K value that's given, we've got a K value of 38,000 at 127 degrees Celsius. Calculate the value of K at 127 degrees Celsius for the reaction below. So with this reaction in mind, given the reaction that's listed above. Well, the reaction down here is the same thing as the reaction up here, except it's reversed. It's the reverse reaction. So I could say that we're going to take the K value to the -1 power. Reaction 0 flipped is the same as reaction 1. So reaction 1 is just turning reaction 0 around. So I need to raise K0 to the -1. K0 is 38,000. So 1 over 38,000, or 38,000 to the -1 power, mean the same thing. I end up with a number 2.6 times 10 to the -5th. All right, using the K value that's given up here, again, we want to calculate the value of K at 127 degrees Celsius for the reaction below. In this reaction, I have just multiplied by 1/2 across that reaction. 1/2 N2, 3/2 H2, and then just NH3. So if I've multiplied the whole thing by 1/2, then K needs to be raised to the 1/2 power. Or we need to take the square root of K, however you'd like to think about it. 38,000 to the 1/2 power, the square root of 38,000, is 190. Okay, example 2 is a little more involved. Given the information above, so we've got two reactions above and we've got their K values. Given the information above, calculate the K value for the chemical equation given below. Remember, the things we can do is we can multiply by some number, or we could flip the reaction around. Those are the two different things we've learned how to deal with in terms of these equations and the equilibrium constants, what we can do with them. So I have CO2 plus 3H2 yields CH3OH plus H2O. I kind of like to look at my products. I see that I've got CH3OH, that matches the products for the second reaction, and I have H2O in the product side. Well, I don't have any H2O on the product side up here, but my first reaction, the reactant side, has H2O in it. That tells me I'm going to need the reverse reaction. So I'm going to turn the first reaction around. We're just going to flip reaction 1. And if I flip reaction 1, remember I have to take K to the -1 power. That's just what we've done. K to the -1 power, that's 1.0 times 10 to the 5th, raised to the -1 power. Then we need to write the original reaction, or the second reaction, just as it is, because it fits that way. We can check our work, and the K value stays the same because we did not flip it, we didn't multiply by anything. It's the same as it was. Check our work by seeing if everything cancels out to give us the reaction that we have right here. So the CO and CO cancel out. When you add them together, you get CO2 plus 3H2 yields CH3OH plus H2O, which is the exact same equation we have above. So what do we do with these K values? Well, first of all, we've got to remember, if you flip it, you do the inverse. And we've done that. We've accounted for that. And I've added them together. So whatever the K values are for these two reactions that I just added together, we need to multiply them by each other. So 1.4 times 10 to the 7th multiplied by 1.0 times 10 to the 5th to the negative 1 power. K overall is 1.0 times 10 to the 5th to the negative 1 times 1.4 times 10 to the 7th. You end up with a total of 140. Okay, then, sorry, I'm getting ahead of myself there. Example 3, we've got these two reactions. Given the information above, calculate the K value for the chemical equation given below. 2A plus 2B yields D. Well, I see A and B here, but we're going to have to double that reaction. That would give us 2C, which would cancel out, and we would end up with D, which is what I want. So reaction 1 needs to be multiplied by 2. And if it's multiplied by 2, we need to square the K value. K1 needs to be squared, 340 squared. Reaction 2 can be left alone as is, so we get 2C yields D. K2 is just 15. And if I wanted to, I need to check my work and make sure that this works out. The 2C's will cancel out. We end up with 2A plus 2B yields D, which is what I have up here. If I'm adding those two reactions together, I need to multiply their K values. So I end up with 340 squared times 15, which gives you 1,700,000.